Okay, so today we're going to talk about writing equations to determine if a table of values is proportional. On the screen you'll see a statement says, does this represent a proportional relationship? Is there an equation? Various questions will be asked of you about proportional relationship. Since we have a table of values, I'm going to show you two different ways. First, we're going to talk about direct variation. Don't really worry about direct variation, just know that your equation you're going to be changing into is y is equal to kx. That is kind of the generic name of direct variation. Later on, we'll talk about distance is equal to rate times time. That's also a direct variation. Direct variation just means as x is overall increasing, so is y, because it's being multiplied. This is going to be your some type of constant change. And this relates to our rate of change or our slope. So on the screen, you have when x is 0, y is 0. So this is input, this is output. So when I put 0 in, I get 0 out. When I put 1 in, I get 4 out. 2, I get 8. 3, I get 12. The easiest way to do is you ask yourself, what can I do mathematically to get the same constant every time? One way to do it we've been doing in class is finding slope. From 4 to 8, 4 to 8 is plus 4, 1 to 2 is plus 1. So my change in y over my change in x is 4 over 1. So this is my constant rate of change. So then you just take this constant rate of change and replace your k with that number. So your equation now is y, this entire y, is equal to 4 times x. How do we check our work? We multiply everything in here by 4, and we should get the same output. So 3 times 4 is 12, 2 times 4 is 8. So we know that this is proportional because we have a constant of multiplying by 4 each time. Okay, let's go to the next example. This one kind of similar to the last one. Does this represent a proportional? Proportional or not? Well, the first thing we need to do is here's y, here's k, so I know that y is equal to k times x. In other words, I'm going to have something multiplied by my constant to see if it works. If you don't want to do the slope for this one, you can figure out what times 5 equals 2, what times 10 equals 4, what times 15 equals 6. Sometimes that's easy to do, but this one isn't going to be nice and neat. So the first thing we're going to do is find the rate of change. 2 to 4 is plus 2. 5 to 10 is plus 5. My constant here is change in y over change in x. Change in y is plus 2. Change in x is plus 5 each time. It works. So I replace this. Instead of my k, I write y is equal to 2 over 5 times x. And you go, okay, make sure I check my work. 5 times 2/5 becomes 1, 1 gives 2. 10 times 2/5, put 10 over 1. 10 times 2 is 20, divided by 5 is 4. So this is proportional. This is definitely proportional because it has the same rate of change, same constant each time. The table represents a proportional relationship, so this one it already tells you this is a proportional relationship. All we gotta do is write an equation to represent it. So here's my x, here's my y. I'm gonna go ahead, since I have my y's there, I'm gonna write y is equal to k x. Remember, x and y are just arbitrary letters. You can make it d, you can make it t, you can make it any variable that they give you or you choose. You don't always have to use x and y. So now we need to find our rate of change, our same constant. What can I multiply by x each time to get y? Well, 1, here's x, something times x equals 1, something times 6 equals 2, something times 12 equals 4. So we're not dividing, we're going to be multiplying. So this tells me that this is going to be multiplying by a number less than 1. So I'm going to go ahead and find the slope. So from 1 to 2, that's plus 1. Okay, from 3 to 6, that's plus 3. My pencil's breaking all over the place here. From 3 to 6, that's plus 3. So change in y over change in x. This one you can do plus 2. This one is plus 6. As long as you're using the same change, 2 over 6 or 1 over 3, it should be okay. So change in y is plus 1. Change in x is plus 3. So my change, my constant, is 1/3. So my relationship here is y is equal to 1/3 x. All I'm doing is I'm taking the slope and I'm replacing my k with that number, and my equation is y is equal to 1/3 x. You can quickly check your work. You can build another t-table if you want. Do x and y. We got x is 3 from this, and y is 1. Well, I know that 3 times 1/3 does equal 1. Same thing with 6. 6 times 1/3 does equal 2. So my equation, this makes it proportional.